So, welcome back. I know it's been a long time since I last posted a video, and after a long time, we are back to complete trigonometric functions, which is the graphs part. So, this is the part that I have a lot of trouble with because it's difficult to draw. So, please bear with me. My drawings here will not be exactly symmetric. It won't be very nice. It sometimes, it will be a bit, it'll look a bit imbalanced. But I'll also try to use a graphing calculator. There is an app called Desmos that we will look at later, and I'll be using that to also help you see how certain graphs look. So first, what are we going to do today? We are going to look at the three trigonometric functions. We have sine, cosine, and tangent, and we are going to look at their graphs. So what do these graphs look like? Because if you have a simple function like if you have a function like y equals to x, right? Y equals to x, we know that the function is basically like a straight line, right? It'll be like this. This is 45 degrees, and this is because we know that it has a constant gradient, right? And the gradient is 1. So we have plotted these kinds of things before. We know how to plot how to sketch graphs like y equals to x or y equals to 3x, 4x. We know how to do quadratics and so on. So now we're going to learn what will a graph like what will the graph of what will the graph of sine x look like, right? So in summary, you can see that it will look like the graphs that I've sketched here very briefly. So the sine graph is this part here, right? And you can see that if you divide this into their respective quadrants, this is where the quadrants will be. Right, this is where the quadrants will be. This is first quadrant, this is second quadrant, this is third quadrant, and fourth quadrant, right? This is how your first quadrant angles are all like 0 to 90 degree. Or if you take it in radians, this is 0 to pi over 2 radians. This is pi over 2 to pi radian, pi to 3 minus 1.5 pi, and then 1.5 pi, 2 pi, right? This is your typical radians. Let me just delete that because it's very messy. So if you look at the sine graph, this is what it will look like, and it will agree with what we have already seen so far, which is, if you remember, the ASTC rule, right? Where in the first quadrant, all sine, cosine, and tangents are positive. In the second quadrant, only sine is positive. In third quadrant, only tangent is positive, and in the fourth quadrant, only cosine is positive. So you can see that where is sine positive? Sine is positive in the first two quadrants, right? You can see that in the sine graph. Similarly, if you look at the cosine graph, it goes from 1, and then it drops into the negative zone. So this will be these are your quadrants: first, second, third, I don't know why, third quadrant and fourth quadrant, right? So you can see that for the cosine, it's positive in the first and fourth quadrants, and it's negative in the second and third quadrants. Similarly, if you look at the tangent graph, this will be the quadrants: first, second, third and fourth, right? And if you see where it's positive in the third quadrant, it's positive in the first quadrant. So this sort of agrees with our ASTC rule and all that we have seen before this, in which quadrants are sines, cosines and tangents positive and negative. Okay, so this is just a brief. So if you're already familiar with this topic and you want a refresher, you want to know what the sine, cosine, tangent graph looks like, that's why I have this summary in front here. Now let's go deeper. Let's start understanding why these graphs look like this, right? Let's start with sine. So I've set up something here. Okay, let's try to figure out what's going on with the sine function. Like we said that the sine function looks like this, right? It looks like this. It goes from it starts at 0 and then it goes up to 1, and then by the second quadrant it comes down back to 0, and then it goes to -1 and back to 0. So let's see why they have this shape. Now we are going to approach this by using the normal table that we normally use to plot a few points on a graph, and then we connect the dots and see how it looks. So first, let's try to calculate the sine values, right? Let's fill up this table on the right. So I have just for your reference, right? You have to be very comfortable switching between radians and degrees, right? So I have both of it here for your reference, but in the exam you can be, not only in the exam but for your understanding, you see, you might be asked to calculate the sine of a value in degrees or in radians, right? So you must be very comfortable switching between degrees and radians. That conversion should be very clear to you by now, and you should already remember in your head that pi over 2 radians is 90 degrees. Some special angles like 45 degrees is pi 1/4 radian. 1/4 pi, right? So you need to sort of you need to have certain special numbers and all that in your head already, and you get this via practice. So without wasting more time, let's go straight into this. Sine of 0 is 0, and what is sine of pi over 2, or sine of 90 degrees? If you go back and look, that should be 1, right? Because if you look at the unit circle that we drew before this, right, the sine is going to correspond to the y value. So if you look at sine 90 degrees is basically this blue line here, and this y value will be 1, right? And then if you go 180 degrees, this is back to 0, and then sine 270 degrees is down here, which is -1, and sine, so let's put that in. So sine 180 is 0, sine 280 is -1, 270 is -1, and sine 360 you go a full circle, so you come back to 0, right? So you have to be able to figure out the sine values for all these angles, and once we know all that, let's just try to quickly plot these points. So I have sine, let me just draw the axis in the same color. One, say this is -1, this is 0, right? Say I have a few points here. First is when x is 0, I know that my sine value is 0, and then I have 90, so let's say 90 is here. This is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, so at pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, it's -1. And at 2 pi, it is 0 again. Right? And if you try to just connect these dots a bit. Sorry, my drawing is not great. Okay. You'll get something like that. Okay? You'll get something like this. And the graph has to be symmetric. So, you know, if you look at each division, this part and this part have to look like mirror images of each other. Although, you know, when I draw it by hand, it sometimes doesn't turn out that way, but it has to be. And you see, especially this part, you can see that, you know, I messed up a bit. It's not exactly the same. This side and this side are not the same, but, you know, please just bear with me. It's difficult to draw on the tab. But what I'll do is now I'll just show you what the sine graph looks like through this app called Desmos, which you can also check. So now I have this red line, which is the sine graph, and this is where we started, right? We started by taking this part. Sorry, actually we took this whole, sorry, we took this whole part, right? Which is which looks like this. You see, all our points are are the same as what we have already plotted, right? This is how a sine graph looks. And what happens, so now what happens when you go, let's say, negative angles, right? What's the sine of negative pi over 2? So it's negative 90 degrees. What is the sine of negative pi over 2? Oops. Oh, I think I have a math solver here that's giving you answers. But okay, so sine negative pi over 2 is -1, right? You remember that sine of negative x is negative sine x. We did show this before, right? So sine pi over 2 is 1, and sine of negative pi over 2 is -1. And so that rule will hold, right? Look at this. This is this point here. This is 1. No, sorry. This is, oops, sorry, sine, this is pi over 2, right? Oops. And if you go to this side, if you look at, oops, sorry, this is supposed to be negative pi over 2, as you can see, and that y value is -1. When you compare these 2 points, the 2 points that I've selected on the graph, you can see that, you know, you have a mirror image on each side of the y-axis. That means this side and this side, they are just reflected on the x-axis, because this tells you that, you know, sine negative x equals to negative sine x, meaning all the sines to the right of this y-axis will be the reflection of the sine on the left of the y-axis. Okay, so that's pretty much what you need to know for the sine graphs. Okay, so let's look at cosine, right? Cosine, similarly, let's not take too much time. I think we are already 15 minutes into the video. So if you look at cosine, if you go by the unit circle, cosine is the x value of each of whatever coordinate you're looking at. So if you're looking at 90 degrees, for example, right, this is pi over 2, 90 degrees, the x coordinate is 0, right? So you know that cosine pi over 2 is 0. If you look at 0 degrees, you know that the x value is 1. And so this will go to -1, and then it will go to 0 again, and then it goes back to -1. 1 when you come a full circle, right? So if you plot this on the graph for cosines, you know, if you plot this on the graph for cosines, say this is your pi over 2, so this is your pi here and here, 2 pi, 3 pi over 2. What you will get is that cosine of 0 is actually 1, and then it comes down to 0, and then when you go 180 degrees or pi radians, it goes to -1, and then it goes back to 0 at 270 degrees, and then you will end up with 1 when you come a full circle. So these are the cosine values, right? And when you plot, okay, maybe I can plot like this. Is this correct? It's not, because if you plot other points, you will realize that, you know, you cannot draw a straight line, and the sine cosine graphs and all, it's not linear. That means you won't have a straight line graph for all these things, right? So it will actually look curved like this. Right, and then you come up here. Okay, it's quite a decent diagram actually, but yeah, it'll look something like this, right? And then let's see what happens when, what happens with sine, say, what happens after this part of the graph, after 2 pi, right? Say you'll have sine, I think the next point here will be sine 5 pi over 2, right, which is 2.5 pi. So you go another half pi, meaning half pi means another 90 degrees. That means you went 360 degrees just now, and then you already have 360 degrees, then you go another 90 degrees. That means this is 450 degrees. So we are asking basically what is sine 450 degrees, right? And that will be exactly, sorry, not sine, cosine, sorry. So cosine 450 degrees, and the answer for this will basically be the same as cosine 90 degrees, which is 0. So this graph will come down here, and you will notice that, you know, this graph will keep going. So your cosine graph also look like that, you know, it'll keep going, right? And I mean, of course I didn't draw it very nicely, but this holds for both the sine and cosine graphs and tangent as well, right? There is a pattern that repeats. So even for the sine graph, this is going to look like, you know, so I had like this, right? So it's going to go up again, it's going to come down again, you know, it's like that. So as you can see, the sine graph, it's like, you know, you have one cycle, which is this part that we drew just now. This is 0, this is 2 pi, right? And then this is another cycle, this is another part, and then this is another part. See, every 2 pi it repeats. So this is 4 pi, this is 6 pi, and so on. Okay, now same thing when you have a cosine graph. Now you look at the cosine graph, this is the part that we have looked at so far. We have very specifically looked at this part of the graph, where this is basically 0, and this, oops, sorry, that's oops, that is 2 pi, and this is 0, right? So if I take out the annotations, I just show you these points. See, this is exactly the same as what we drew, and you see that this cycle will sort of repeat. So first we have this to this area is 0 to 2 pi, and then it will repeat again. This is 4 pi, right? You see the same shape, oh sorry, you see the same shape holding. This is 6 pi. The same thing repeats again and again. Okay. Now, okay, maybe we can stop with sine and cosine first, or maybe I'll just finish tangent. I'll just show you the tangent graph also. So this is how sine and cosine graphs look like, right? And long story short, you can see that, you know, we have already covered this. Right? We know now why sine graphs and cosine graphs look like this. Next, let's look at what the tangent graphs look like. Well, for the tangent graph, I'm not going to focus so much on the numbers 1 and 0, so because it's really not, let's not try to plot too many things, but instead let's just try to understand what happens to tangent, right? So if you have the unit circle, right, and then you have the unit circle, right? Okay, we normally use this circle to identify tangent, and what we do is for sine, we take the x coordinate, the y coordinate. For sine theta, we take the y coordinate. For cosine theta, we take the x coordinate. For tangent theta, we take the y coordinate over the x coordinate, right, which is the gradient of the line. So if we have an angle theta, right, the gradient of this line equals to tangent. So now if we have a line that is, so first let's try to figure out. We have x, say x is 0, right? That's a flat line. Look at this black line here, that's a flat line. So flat line has gradient 0, so tangent of x is 0. Tangent of theta is 0. Let me just put theta, maybe, so they don't get confused. Okay. Well, if theta is pi over 2, meaning 90 degrees, right? What is the then what do we have? We have a vertical line, right? Because 90 degrees is like that, and then your line is a vertical line. Well, what is the gradient of this line? This gradient is actually, actually it's undefined, right? If you want to calculate using y over x, y over x here is y is 1, x is 0. This is undefined. So this is actually undefined. Okay? Or basically it's the gradient of a vertical line, it is extremely steep, meaning it's almost infinity. Right? So it goes extremely large. So what you see on a graph is that if this is pi over 2 and this is pi and this is 2 pi and so on, right? 3 pi over 2. Okay. You started off at 0 and you go up, but you keep going infinitely high. And this line will never touch, this pi over 2 axis. Because when you take tangent of pi over 2, there's no value, it's too big. So if you look at the asymptote, right, you draw an asymptote here, and basically these two lines shouldn't touch, although I think I've sort of touched, but wait. These two lines shouldn't touch actually, but maybe I should. But yeah, you get the idea, right? That this is an asymptotic function. Meaning like that, right? Where as you approach 90 degrees, the tangent gets very big, right? Because your line is getting steeper. And so that is what happens when you take tangent. And when you take tangents for other angles, right? Let's go back to that same unit circle. So if you go back to this unit circle and then you want to find now tangent, let's use purple, tangent pi, right, which is tangent of 180 degrees, right? And what is this? Well, tangent pi is another flat line, right? This is 180 degrees, another flat line, so this is 0. So tangent pi is 0. And what is tangent? Let's say tangent somewhere in between pi. So we have like infinity for 90 degrees, and then we have 0 when it's 180 degrees. Let's take an angle somewhere in the middle, right? This thick purple line that I've drawn here. Well, here the gradient is negative because this is a downward sloping line, correct? Or if you want to take the y coordinate, the y coordinate is positive but the x coordinate is negative, so y over x is a negative number. So the tangent of anything in the second quadrant, which is this area here, this area here, this blue area here, anything in the second quadrant, actually the tangent is a negative number. And so what you'll see is it starts from negative infinity and goes to 0. and then tangent in the third quadrant, right, will basically follow tangent in the first quadrant, and you will have an asymptotic line again. Okay, meaning if you look at tangents inside this third quadrant, right, again you see this is an upward sloping line. This is a positive slope. So in the third quadrant, in this yellow quadrant here, tangent is positive. So tangent is negative here, positive here, positive here, and it will be negative again in the final quadrant. So in this final quadrant here, between 3 pi over 2 to 2 pi, here tangent will be negative again. So let's draw asymptote. Oops. Okay, you will find that tangent is like that. So it goes from negative infinity to 0 again. So this is the fourth quadrant. I will just color the quadrants accordingly so that you can sort of look at the logic a bit. Okay, this is a half an hour video, so I think I'll just stop here. I hope it's clear that these are the patterns for your sine, cosine and tangent graphs, because I do not know whether it's worth explaining too much. I mean, this is the explanation for it. There's really nothing else to explain. So okay, so yeah, let's take a look in the next video then. Maybe we can look at more applications of the graphs. So we'll just go through some modifications to these graphs, and then intersection with straight lines and how to solve simultaneous equations, and then we'll be done. Okay, thank you and see you.